video what we are going to see is how to find the values of k vector and the lambda. And as I said before, k vector happens to be the eigenvector and lambda is the eigenvalue. But let's begin. Okay, so same procedure. If this is the solution, then we have to replace it in the differential equation and then find the values of k vector and lambda, just like in the previous video. Okay, so what we have to do is what it is on the left and what is on the right and make it equal. So on the left, what we have is the derivative of x vector respect to the time. So what is the derivative of this? K vector is a number, so we don't move the k vector, but here the variable is the t. Okay, so the derivative of this is going to be lambda exponential of lambda t. Okay, so that is the left. And on the right, what you have is A matrix times the x vector. Which vector is this one? K matrix exponential of lambda t. And we are going to work with this section of the equation. Okay, so what we are going to do is we are going to pass this to the other side. So it's going to be A matrix k vector exponential of lambda t, and then minus k vector lambda exponential of lambda t equal to 0. But be careful here, it's not 0 scalar, it is 0 vector, because we are in the matrix differential equations. Okay, now let's factorize what we can factorize. I can see here that the exponential is the same, so we can factorize the exponential. A matrix k vector minus lambda. Lambda is a number, it's not a vector. K vector, and then exponential of lambda t, and then equal to 0 vector. Okay, because we have a multiplication here, we have two options. Either this is 0 or the exponential is 0. But the exponential of lambda t cannot be 0. Why it cannot be 0? Well, if this exponential is 0, then we have x vector equal to 0. So if we have the exponential equal to 0, then we don't have solution. So we need the exponential to be different than 0 to have solution. Okay, so because this cannot be 0, then the only thing that can be 0 is the left. So the only thing is A matrix k vector minus lambda k vector equal to 0 vector. Okay, now I can see here that also the k vector is the same, so we can factorize it. But be careful here because it is not a number, they are vectors. So you have to be very careful with the factorization. So let me remind you this. What happens if you have x times y plus x? How do you make the factorization? So what you do is y plus 1x. So you factorize the value of x. But because here is y, well, then you leave the y, but then here, because you don't, the x is alone, so what you have as a factorization is the 1. Okay, that is very simple in algebra, but it's not that simple in matrix. Check this out. If we factorize the k vector because it's the common variable, then we will have A matrix minus lambda k vector equal to 0 vector. But here we have a problem. Why we have a problem? The matrix, the A is a matrix and the lambda is a real number. So this operation doesn't exist. Okay, so how do we factorize in matrix, algebra matrix? So what you have to do here is, if you factorize the k vector, what you have to do is A matrix minus lambda identity matrix. And this identity matrix is the equivalent of the one in the normal algebra, right? So when you factorize the k vector, what you leave behind is the I matrix. Just like here, when you factorize the x, what you left behind is the number 1. Okay, so I hope that is clear. And what is the identity matrix? It's just the matrix with the ones in the main diagonal. Okay, now what we have to find is this system of equations, because it is a system of equations. Okay, now So, because again we have a multiplication here, we have two options. Either the k vector is equal to 0 or this matrix to be equal to 0. Now, k vector cannot be 0. Same reason as before. Different than 0. Why should be different than 0? Because if the k vector is equal to 0 vector, then we have no solutions. So we need the k vector to be different than 0 to have solutions. Okay, so the only thing to be 0 is on the left, alright? But we have a matrix now. Here is, for this to have a solution, what we need is this different than 0. Also, equal to 0, but we are going to do some skips. For this to have a solution, what we need is the determinant of A matrix minus identity matrix equal to 0, alright? Because it's the only thing that can be 0, because k vector cannot be 0. But I cannot make all the matrix 0 because the A matrix happens to be different than 0. What we need is the determinant of A matrix minus lambda identity matrix equal to 0. Okay, now, this is the first equation that we are going to use. So how many variables do you have in this equation? Well, what you can see here is the only variable is the lambda, because k vector is outside of this equation. Now, for this equation, we are going to use it to find the values of lambda. Okay, let's use the previous problem. In the previous problem, in the previous example, the equations was like this. Derivative of x vector, sorry. The previous problem was derivative of x vector respect to the time equal to 1, 3, 5, 3 x vector. And if you remember, the first solution was 1 and minus 1 exponential and minus 2t. Okay? And then the second solution was 3 and 5 exponential of minus 16. Okay, now what we are going to do is use this formula to find the values of minus 2 and minus 6 because they happen to be the values of lambda. Okay, so let's do it, engineers. This is the A matrix. So what you have here is the determinant of 1, 3, 5, and 3 minus lambda, the identity matrix. Because this is 2 by 2, then the identity matrix is 1, 0, 0, 1. And this determinant must be equal to 0. Alright? Okay, now, so this operation is going to be equal to the determinant of what? 1 minus lambda, and then 3 minus 0, just 3, and then 5 minus 0, just 5, and then 3 minus lambda, 3 minus lambda. And that determinant must be equal to 0. I usually write the determinant with 2 bars, with 2 lines. 1 minus lambda, 3, 5, 3 minus lambda, equal to 0. Okay, so let's do the determinant. The determinant is this times this minus this times this. So it's going to be 1 minus lambda times 3 minus lambda equal to, minus 15, and that should be equal to 0. Okay, so let's do the multiplications. 3 and then minus 3 lambda, minus 3 lambda, minus lambda here, minus lambda and then minus 3 lambda, and then plus lambda square, minus 15 equal to 0. Lambda square, minus 4 lambda, and 3 minus 15, minus 12 equal to 0. Okay, now, two numbers, we have to find the values of lambda so that this is equal to 0. So tell me two numbers in which the multiplication is minus 12 and the addition is minus 4. So minus 6 and plus 2. The multiplication is minus 12 and the addition is minus 4. Okay, so I can see here what are the values. Lambda 1 is equal to 6 and lambda 2 is equal to minus 2. Or you can choose the other way around. Lambda 1 is equal to minus 2 and lambda 2 is equal to 6. Alright? By the way, I have a mistake here. This is positive. Now, as you can see here, we have found the values of lambda. -2, and check this out, -2, and then 6, and here is the 6. So, engineers, this is the procedure to find the values of lambda. Alright? So, we found the values of lambda. What about the k vectors? Okay. What about the k vectors? Okay, for the k vectors, we are going to use this equation. Alright? But I will need more space. So I'm going to erase this part and then use this equation. Okay, so I'm going to erase this part and then use this equation. But I'm going to use the first value of lambda. Lambda 1 is equal to -2. So I'm going to use this equation, so it's going to be a matrix 1, 3, 5, 3 minus the value of lambda. I'm going to replace the value of -2. Identity matrix 1, 0, 0, 1, and then times k vector, k1 and k2, and that should be equal to my 0 vector. As you can see here, I'm using this equation. This equation was only to find the values of lambda. Now, this equation includes the value of k vector. From there, we are going to calculate the k vector. Okay, so let's reduce this one. It's going to be minus times minus this is positive 2. So 1 plus 2 is equal to 3. And then 3 minus 0 is 3. And then 5 minus 0 is 0. And then 3 plus 2. Sorry, this is 5. 5 minus 0 is 5. 3 plus 2 is equal to 5, 0, and 0. So you have a system of equations. So what you have to do here, engineers, is you have to make the step matrix. In Spanish is escalonar la matriz. Okay, so what I'm going to do is 1/3 of the first row and save it in the first row, and that is equal to 1, 1, 0, 5, 5, 0. And then what I'm going to do is -5 the first row plus the second row, and we save it in the second row. Okay, so what is the result of that? 1, 1, 0, and then 0, 0, 0. -5 times 1 plus 5, 0. -5 times 1, -5 plus 5, 0. So here is a very important step. You got one row equal to 0. Then if that happens, then you are okay. This shall happen. If it doesn't happen, then you did something wrong in the procedure. Okay, so what is left from that is this one. So because this is the matrix times the vector, so this is k1 and k2, so k1 plus k2 is equal to 0. So that means that k1 is equal to minus k2. Okay, so here it comes a very tricky point. Here what you have to do is to assign any value to either k2 or k1 to calculate the other one, except 0. You have to choose a number, any number that you want. I recommend you an easy number, all right? Because to have the numbers easy, but you cannot choose k equal to 0, because if you choose k2 equal to 0, then k1 is equal to 0. And if both numbers are 0, then you have 0 vector. That means that you have 0 solution, which is not possible. Here you cannot have k vector equal to 0. So let's choose another number. Let's choose k2. Let's choose k2 is equal to 1. So k1 is equal to -1. Okay, so what is the solution? x1 vector is equal to, according to the solution, we propose the solution to be x vector equal to k vector exponential over the lambda t. So we have k1 is equal to -1. Let's choose k2 is equal to 2. Let's choose k2 equal to minus 1, so that means that k1 is equal to 1. You can choose another number, but here is 1 and 1, minus 1. What is the value of the lambda? Minus 2t. And you can see here we have calculated the first solution. So engineers, this is the procedure to find the solutions. You first find, with this equation, you find the values of lambda, the eigenvalue, and then with this procedure you find the values of k vector. Now, let's do the other solution. This is the procedure only for lambda 1 equal to 2. Let's do it for lambda 2 equal to, what is the other value of lambda? 6. And we should get 3 and 5. Okay, let's see what happens. I'm going to skip some steps because I don't have much space here. So what I'm going to do is replace this equation. So it's going to be the matrix A minus lambda identity matrix. So is this matrix 1, 3, 5, 3? But then it's going to be affected by the value of lambda, but only in the main diagonal, and the value is going to be 6. So it's going to be 1 minus 6. The other value doesn't affect, 3, and then 5, and then 3 minus 6, and then equal to 0. 0 vector. Why is equal to 0? Because I am here, alright? And the first column is k1, and the second column is k2. So what you have here is minus 5, 3, and then 5, 3 minus 6, minus 3. 0 and 0. And here I'm going to do just one multiplication. I'm going to do row 1 plus row 2 and save it in row 2. Okay, so what you have is minus 5, 3, 0. So what you have is this plus this, 0, and this plus this, 0, 0. So this should happen again. If that doesn't happen, then you did something wrong. Okay. So what you have is only this equation. Minus 5k1 plus 3k2 equal to 0. I'm going to clear whatever variable, 3k2 equal to 5k1. So k2 is equal to 5 over 3k1. And here comes the tricky point. You have to choose a value of k1 or a value of k2. It's up to you, engineers, but never choose k equal to 0. So what I'm going to do is to choose k1 equal to 3. Why 3? Because it's going to cancel with this 3. So k2 is equal to 5. Okay, so what is the second solution? Second solution, engineers, is going to be k1 is 3, the vector, and then 5 exponential of 60. And this happens to be the solution of this, the second solution. So this is the procedure to find the solutions. As you can see, is very easy. You need only to practice. However, we have to see more examples because in this case, when calculating the values of lambda, what happens here is that you have real different roots of lambda, of the eigenvalues. And remember, if you have real different roots, you could also have real repeated roots, and you can also have imaginary roots. So what to do when you have those cases? That will happen in the next two videos.